What we learned earlier is I always give you y equals f of x, and I try to find dy over dx. So I'm looking for the derivative of this function of x, and this y on one side, and I have x on the other side. So this y is a function of x. If I can write it that way, then this is called an explicit form. But sometimes you have something that would be called implicit, which means it's not that obvious. Okay, implicit. What is the implicit form? For example, I'll give you a quick example. Xy equals 1. See, when I give you this equation, that actually infers y equals 1 over x, right? This is the explicit form, and this is the implicit form. So that has both x and y. And sometimes when you take the derivative of something like this, you cannot really get rid of y. And that is okay. So this is a very interesting concept. It's very different than the like a solving equation or things like that we did earlier. Okay, so let me give you one example how to find the derivative dy over dx given they have this relationship. Okay, so how should we do that? Then we are going to take the derivative on both sides. So I get a d dx of xy and the right side dx 1. Okay, so I take the derivative on both sides. And the right side is very easy because for 1 it's just 0. And the left side is the product, right? The product rule. So do you remember fg prime will be f prime g plus fg prime? Okay, so this one is going to be this f prime, which is the f prime, that's x prime, because we are taking the derivative with respect to x. So just 1 times y plus x times the derivative of this guy with derivative of that with respect to x. So that's dy over dx. Okay, now this is the whole piece. Okay, it's not really the fraction, okay? It just looks like a fraction, so please don't think it's just a fraction. So we got a y plus x dy over dx equals 0. To solve for that, we subtract a y on both sides. So I get a x times dy over dx equals negative y. And then I divide it by x. So dy over dx will be negative y over x. Okay, you can do it this way. You can leave it like that. Or if you don't really like it, you can look at your original equation. You have xy equals 1. So you might want to have something looks like just with x. So you're going to multiply by x, multiply by x. So the top is going to be xy. The denominator is x squared. But given x times y is 1, so the numerator is 1. Therefore, should be negative 1 over x squared. Okay, so what about this one? What about if you rewrite this y equal this explicit form, that's x to negative 1. So y prime, that will be negative 1 times x to negative 2. Is that negative 1 over x squared? So you should get exactly the same thing no matter which method you use. But this is we're treating that as implicit form, and then we take the derivative, and then we can get that answer. Okay, so let me give you another example. Sometimes, like this one, you can even write that as the explicit form, but sometimes, a lot of times, you don't know how to do that. So let me give you this example. Y to the fifth plus 3y squared equals x to the fifth plus 5x squared. It's a little different, huh? Okay, so we have x and y, and there's no way for me to write y equals f of x. I cannot do that. So I will take the derivative of this side and the right side. So I do that, okay? And then I take the derivative of this, which is using the chain rule. Okay, so that's going to be 5y to the fourth and take a dy over dx, isn't it? That's the derivative of this one. And this one is going to be plus 6y, then dy over dx. Okay, now the right side is much easier because they only have x. So I get a 5x to the fourth plus a 10x. Okay, now what we're looking for is dy over dx. It seems like you're solving this for dy over dx. Therefore, you take dy over dx, and the inside you have 5y to the fourth plus 6y, okay, or you can use parentheses, equals 5x to the fourth plus 10x. So dy over dx, you just divide it by this guy on both sides. You get a 5x to the fourth plus 10x. The denominator is 5y to the fourth plus 6y. Done. You're not going to do anything further. You just leave it like that. You'll find it. Okay? So that's how you find the derivative of the implicit form expression or equation. Okay, so that shows the relationship between x and y. Okay, so we're going to work on another example. This one. X squared plus xy plus y squared equals 25. All right, we take the derivative with respect to x. So x squared plus xy plus y squared. And the right side, I also take the derivative with respect to x. Now the left side, dx squared with derivative of that with respect to x, I get 2x. Okay, so that's the first one. Plus, and this is like the product or use the product rule. So the derivative of this one, that's just 1. So it's 1 times then dy dx. Okay, plus x, we take the derivative of this one, y, and then plus x, then dy over dx. It's so easy to mess things up. Okay, I go ahead. And this y square chain rule, I get a 2y, then dy over dx. And the right side is very simple, 0, because the constant is just a derivative. Let me just write it a little better. So I get a 2x plus y plus x dy over dx plus 2y dy over dx equals 0. And then I'm solving for this. I'm going to move everything to the other side. And this 2 term, I'm going to take out dy over dx. So I get a dy over dx. I factor that out, I get x plus 2y left. And the right side, I get a negative 2x plus y. So my dy over dx will be negative 2x plus y over x plus 2y. That's it. You cannot simplify any further. If you're given this equation and then I ask you to take the derivative of y with respect to x, that's how you get your answer. Sounds interesting, isn't it? Okay, so let me make a little easy example to explain this better. X squared plus y squared equals 25. Can you take the derivative of y with respect to x? So again, I write d dx x squared plus y squared, which is the derivative dx of 25. So that is 2x plus 2y dy over dx, right? That's the left side. The right side is 0. So when I solve for dy over dx, I cross out this 2 and I subtract x on both sides and then divide it by y. So my dy over dx equals negative, okay, x over y. All right, so this is your answer. What does that mean? If you remember this x squared plus y squared equals 25, is that a circle with the radius 5 centered at 0, 0, right? Okay. So what is dy over dx? For any given x value, and you have a y, and here, this tangent line, the slope of this tangent line is this. Okay. So for example, if I give you x equals 4, y equals 3. Okay, so you know that a 4 squared plus 3 squared is 5 squared. So this point, 4 comma 3, this point is definitely, this is my x, this is my y, it's definitely on this circle. And this slope is a 3 over 4. So this line has the slope, negative reciprocal should be, this this slope is 3 over 4, so this slope is negative 4 over 3. Isn't it? Isn't it just negative x over y? Because given this point xy 4, 3, is that a negative 4 over 3? So it does agree with what we learned long time ago, right? So it's interesting. Then you see that for this implicit differentiation at the end, when you give me the answer, you don't really need to write that into like a format of a function of x. You can leave the y there, okay? That is okay. And you can tell by this example that what does that mean? Because for this original equation, if you have x, y satisfied this equation, and at that point, your graph have the tangent line with the slope of this. So that's why you don't really need to write that into the format just purely with x. Okay. Okay, we work on more examples. I think this one is going to be very complicated. 3x squared plus y squared equals 100xy. Scary, isn't it? Okay, we're going to take the derivative with respect to x. So square y squared, square y square, okay, equals d dx 100xy. All right, now it is complicated, but we can still do that, right? So this is the derivative of this is going to be 3 times, and then we'll bring this 2, and then so we have x squared plus y squared. Chain rule, then we have to take the derivative of this with respect to x. So that's going to be 2x, see that's the derivative of that, plus 2y, then dy over dx. See that? Okay. Now the right side is multiplication. We can just treat 100x as one, like the p and this f and the g. So the derivative of that is 100x, derivative is 100, and then y, okay? Plus the derivative of this, so I copy this 100x and then dy over dx, the product rule, right? All right, so I need to solve for dy over dx. So let me just make it a little easier. This, and this. This four, five, 1, 2, 3, 4. There's 4 terms multiplied together. 3 by 2 by 2, which is 12x times x squared plus y squared. Okay, so this times that becomes 12y times x squared plus y squared, and then dy over dx. And the right side, I have 100y, I have 100x. So far, I just leave it like that. Okay. And then I need to move all the terms. I need to put all the terms with the dy dx on one side, and I bring all the others to another side. So I get a 12y x squared plus y squared dy over dx. That's this term. And I subtracted that on both sides. I got a minus 100x dy over dx. All right, now the right side, I have 100y, and then subtracted this on both sides. I go minus 12x x squared plus y squared. Okay, and then I need to factor out dy over dx. So let's see what's inside. I get a 12y times x squared plus y squared minus 100x equals, the right side, I don't have to write that. So it's 100y minus 12x, x squared plus y squared. I'll keep that at this moment. And then I'm going to divide it by this on both sides. So my dy over dx will be 100y minus 12x, x squared plus y squared. And the denominator is 12y, x squared plus y squared minus 100x. And all the numbers are divisible by 4, so I just divided by 4. Everywhere, I get a 25y minus a 3x x squared plus y squared. See what I'm doing here? I divided by 4. So I get a 3y x squared plus y squared minus 25x. It looks weird. It looks very complicated, but this is your answer, believe it or not, that's your answer. Okay, so why we get when we get this answer, I want to tell you how to use that for the next step. You know the graph looks like this. Looks like that is this. 3x squared plus y squared equals 100xy. If you graph that in your graphic calculator, it's this. And that there is a point 3, 1. That's your x, that's your y. That's on the point. Now you see that x squared, which is the 3 squared, that's 9. And here y is 1, so y squared is 1. So 9 plus 1 is 10. 10 squared is 100. So the left side is 300. And the right side, 100 times 3 times 1 is also 300. So we know that 3, 1 is here, right? What about if I ask you, what is the tangent line? For this tangent, what's the slope of this tangent line? Then you just need to plug in x equals 3, y equals 1 into that. You can get the slope. So the slope will be, isn't it interesting? So it's going to be, the top is going to be 25y, so 25 times 1, minus 3 times 3, okay, x squared plus y squared, so it's 3 squared plus 1 squared, divided by 3 times y times x squared plus y squared minus 25 times 3. So the top is 25 minus, okay, 3 squared, which is 9, plus that is, plus 1 is 10, so it's 90. Okay, the denominator, that's 10 times 3, so it's 30, okay, minus 75. So the top is 65, it's negative 65, the bottom is negative 45. So that should be, you divide it by 5 everywhere and also get rid of the negative, you get a 13 over 9. Believe or not, you get the slope. You know the point, you know slope, okay? So you know point, you know slope, so you can use this to get this, to get the equation of this line. Okay, so that's how you use this implicit differentiation. Basically, we just use the rule we learned in earlier videos, in earlier chapters or sections. So I don't think there's really nothing more that I would like to talk about for this implicit differentiation. Okay.